Welcome back to the workshop one last time for section 9.1, talking about sequences. We have a few definitions, a theorem, and an example to go over, so there's actually quite a bit here in this last video. So we want to talk first about monotonic sequences. A sequence is monotonic if a sub n is less than or equal to a sub n plus 1, so each term is smaller than the next, or a sub n is greater than or equal to a sub n plus 1. So either each term is smaller than the next, or each term is larger than the next. So you can also think of that as the next term is always larger, or the next term is always smaller. In the case of the next term being larger, this is said to be increasing, monotonic increasing. And in the case that the next term is smaller, we would say that it's monotonic decreasing. All right, so that is what a monotonic sequence is. It's either increasing or decreasing. Technically, if we have a constant sequence, it's both increasing and decreasing because we do allow for equality here. So the next thing we want to talk about is a bounded sequence. What does it mean to be bounded? Well, a sequence is bounded above if there is an m, a real number n, such that each of the terms in the sequence is less than or equal to that number n. So if I have, I can go up pretty high, but then I'm going to end going back down, right? I'm going to be bounded above at this line. I'm going to be bounded by. A sequence is bounded below if there is an n such that, again, a real number n, such that a sub n is greater than or equal to n. So we're bounded above if we're always below something, and we're bounded above if we're below something, and we're bounded below if we're always above something. And then to say that a sequence is bounded simply means that it's both bounded above and below. So it's bounded if bounded above and below. Excellent. So that is monotonic sequences, bounded sequences. And our theorem puts these two ideas together. If a sequence is bounded and monotonic, then it must converge. So bounded and monotonic. Now, what's quite convenient is typically if something is, bounded above and increasing, then that allows us to also conclude that it's bounded below. But we can get more into that later. So, if a sequence is bounded and monotonic, then it converges. Essentially, as a quick image here, if we have some sequence of values that's increasing, but they're bounded above, then eventually they have to kind of flatten out. Now this value that we're bounded above by doesn't have to be exactly the limiting value. We can pick some value that's actually higher, whereas the limiting value might be L, which is lower. Okay, so the bounded value doesn't have to be exactly the limiting value. All right. So let's take a look at these two examples here. For the first example, in each case we want to determine if the sequence converges. And for the first case, we want to look at this terms being given by 2 plus 1 over 5 to the nth power. So this is going to look something like 2 plus 1/5, 2 plus 1/25, 2 plus 1/125, and so on. So we're increasing 2 by a smaller value each time. So 2 plus a fifth, 2 plus a little less, 2 plus even less, 2 plus even less. So this is actually decreasing. We can notice that a sub n minus a sub n plus 1 would be equal to 2 plus 1 over 5 to the n minus 2 plus 1 over 5 to the n plus 1, which is equal to 2 minus 2 cancels out, and if I want to find a common denominator here, I would have 5 over 5 to the n plus 1 minus 1 over 5 to the n plus 1. So this would be 4 over 5 to the n plus 1, which in each case is greater than or equal to 0. So that means that this term minus the next term is greater than or equal to 0. And that actually compares to this right here. So any term minus this term, if I subtracted this from both sides, I would get a sub n minus a sub n plus 1 is greater than or equal to 0. So this tells me that the sequence is monotonic. And it is decreasing. Excellent. So is the sequence also bounded? Well, yeah. So we know that we're never going above 2.2 here. But we also know that we're never going below 2 because I'm always adding something to 2, right? This is never going to be a negative number, so I'm always adding something. So a sub n is bounded below by 2, hence a sub n converges. A sub n is monotonic decreasing and it is bounded, therefore it converges. That's exactly what our theorem says. All right. For our next example, we're looking at a sub n is given by the sine of n times pi divided by 6. Now, we had an example where we found that cosine of something did converge. And here we're looking at the sine of something. But we want to recognize what happens. So, of course, it's bounded, first of all. A n is bounded. Because we have that each term lies between -1 and 1. And then we have also that the sequence is given by sine of pi over 6 would be 1/2. The sine of 2 pi over 6 would be square root 3 over 2. Yep, that's root 3 over 2. Yep. That sounds right. All right. And then we have sine of 3 pi over 6 would be sine of pi over 2, which is 1. But this is where it gets interesting, right? So we've increased, but as we continue, the sine of 4 pi over 6 would actually be square root 3 over 2 again, which means that we've decreased. So we've been increasing and then we decrease. So this sequence is not monotonic. Does that necessarily mean that it doesn't converge? No. because if I were to add a coefficient of 1 over n, then this would in fact converge still. As it sits originally, it does not converge because it's an oscillating sequence and it oscillates between -1 and 1. So we would in fact conclude that AN does not converge because it oscillates from -1 to 1. So we don't conclude that it doesn't converge because it's not monotonic. That doesn't mean anything. There are sequences that are not monotonic that do converge. So we want to be careful about that. In this case, it does not converge because it oscillates from -1 to 1 forever. And that's it for section 9.1. Yay! We're finally done with a section. Of course, there will be much more to come as we continue moving on through chapter 9 and into chapter 10. I'll see you guys in a little while. I hope you have a wonderful day.